So I have my IntelliJ open, and let's start solving this problem here. I will take exactly the same method name as given here in lead code. And I prefer to mark these arguments as final, make them immutable. Okay, so here we are dealing with in terms of rows, right? So once I think we don't need to have a 2D array because we are dealing one row at a time. So I will try to optimize the space by using only 1D array for my DP. So let me show that how to do that. So I will just create one row because we are only dealing with one row, and it would be each row would be having the number of columns as n, right? And for example, n is 7 given here, so it would be for each row. So this row is actually representing this from 1 to 7. This is like 1D array, or the row that we have just presented here. And to start with the base case, right? I will just put arrays.fill. I will fill it with 1. It means that we have got all this this particular say for example row, everything is 1 already, which is our base case as well. And now so for the last row, we don't need to take care of it because we have already initialized it with 1. So we'll start with the remaining 2, m is equal to 0, m is equal to 1. These two rows, and then we'll deduce the algorithm that we have already calculated. It should be sum of the right to the down. So let's implement the same here. So as mentioned, I don't need to take care about the last row. I will just take the remaining number of rows which are left is m minus 1. Okay. And now here I will actually create each row individually. Okay. And it would be again n. For example, right now I am here at this, talking about this row. So I will, for each of the rows iteration, I will create a new next row, call this next row, and then try to calculate it. And this row would be used as the final row, which we will use to do the calculation, because we need this row to do the calculations for finding the elements of this m is equal to 1 row, this one, the next row. Okay. So again, let's start with the base case, that arrays.fill next row should be 1, right? Which means that the last column is also 1. I'm talking about this cell, because as you know that we have, for all the n is equal to 6, I mean all these column elements are also 1, same as the last row, because they cannot move down here in this last row, and here they cannot move to the right. It's only like one way possible down. So when we take this next row, that is m is equal to 1, we have already marked it as 1. Now let's try calculating for the remaining rows. So I will just take it as, say, j is equal to, okay, we need to start from n minus 2, right? So n minus 2. We are here, n is equal to 7, so we have to start from here, because 6 is already marked as 1. We start from this cell, which is n minus 2. And we will move till 0, because we have to calculate from this cell to this cell, and it's equal to 0. And last would be j minus minus. Okay. Now here our calculation goes the same formula as we discussed, that it should be the next row j, I mean this one, should be the sum of this plus this, sum of this and this. Okay. So it should be next row j plus 1 plus row j, because right now our row is pointing to the below one, right? So it's this one, row j is 5 here, j is n minus 2, 5 here. So this is our next row. Similarly, it keeps on calculating the same formula. So suppose if we are at this cell, it would be 2 plus 1. 2 is this and 1 is this, and so on until it reaches to the last cell. And then finally, we update our row to the next, because this is our, once we have calculated all this m, then we need to move the next row to the first one, and the row would be becoming the previous one, which is m equal to 1. So this is what we are doing here. This is all the algorithm about. And then let's return the solution, which is at row 0, right? This is the final solution. So this is the way. I mean, I didn't want to have a 2D array to represent this, because here this is a simple solution. We can only treating one word at a time. Okay, so let's try to run this problem with the examples given. I will just write unique paths 3, 7, right? Let's run this. Okay, so the answer is coming correct. Let's try to copy this solution and run in lead code to cover all the different edge cases. I'll just make some space here and let's run this. So running works well. Let me submit this. Yeah, so it works well. And let's try to quickly do the time and space complexity. So as we can see that the time complexity, right? Because we are actually doing 2 for loops, right? For here, which is till m, and then n. So it would be roughly O of m into n, right? And for the space complexity, because we are only maintaining like 1D array here as well as here, so it would be just O of n, right? Because n is the number of columns. So this was the time and space complexity, and this is all about a unique paths problem. So in the next video, we will solve the 20th problem of our tutorial series on dynamic programming, which is minimum path sum, and we will solve this problem in lead code. This is very much similar to how we solve the unique path problem. So that's why I had just included it as the next problem.